to the cloud.
Roger that.
Okay, well, welcome to the August 3rd, 2021 session of Tangerine SDR and Hamsci technical session. Somebody's making a lot of noise. My name is Dave, KV0S. And this week I've been continuing rearranging my ham shack, and all the vital things are up and running, and but still putting bits and pieces back together. So that's about it for me. Next on the list we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Let's see. This weekend, yesterday was the Society for Amateur Radio Astronomy Conference. And so I gave a presentation on how the Tangerine SDR could be used for radio astronomy applications. And that involved, I got some input from Dave Typinski from the Radio Jove project. And then that also involved writing the paper that many of you were on, and we did a good review of the design with Scotty and Tom McDermott and John Ackerman. So I think that went very well. And then Veronica Romanek also gave a presentation on the grape yesterday. So we made it through there. And then now we're, today I had meetings with the students all day today. And so then the next big deadline is, let's see, this Wednesday is the AGU abstract deadline. So I know Joe W7LUX is on here. I'm working on getting that put together. I probably have one or two more questions, but getting ready for that. So just trying to keep everything moving along. And after we get through AGU meeting deadline this week, we'll probably talk about TAPR DCC next week. W2NF back to net.
It's coming up. TAPR's busy planning for the structure and the process. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Well, I'm doing a paper for DCC in which I'm documenting the susceptibility or lack thereof of the magnetometer to nearby heavy-duty RF like you'd have in an antenna farm of a ham radio operation, and also documenting what I've done to ameliorate noise that came out of that system when I discovered that. So I decided to rerun all the tests, this time save all the data, and go through and actually do a rigorous statistical analysis of the data to make sure my eyeball on it is actually correct. So what I'm doing is I take baseline in what I call background magnetometer readings with nothing running before, during, and after the test. Then I test the two magnetometers, collect data off of both of them, running 1500 watts on 160 meters through 10, and the 500 watts, rather 1500 watts, 160 through 10, 500 watts on 6, and then 50 watts on 2, and then take the data, and I will do a two-tailed t-test to verify, or rather fail to refute the hypothesis of the null hypothesis, which indicates there's no difference in the mean values of the data after taking data for 1 minute at each set of RF exposure levels. Also, this time I'm using carrier, CW, and voice modulation. So we'll have 3 different kinds of RF stimulation going to the system. So far, the only thing that I've seen that indicated an interaction is that I can put enough RF into the magnetometer with on 80 meters, using my 80 meter dipole at 1500 watts to turn off the I2C. It doesn't burn it up, it just quits working. Then back off the power to a kilowatt and it starts working again. So yeah, you can, it didn't change the what the magnetometer was saying as far as readings, it just stops working when you put enough RF close to it. And it's in a particularly bad location. I mean, it's fairly close to where the dipole, which is not high up in the air. It's a cloud heater. It's up about 15 feet and it runs right over the magnetometers. So I thought the fact that you don't get a lot of change in the magnetometer readings, that it just quits working at some point, and it comes back as soon as you back off the power. So anyway, I'm going to document all that in DCC presentation and also put in a paper on it so that folks will have the records of that testing. Hopefully will, can improve our level of confidence in the magnetometer we're working on. So that's my report for the week. Back to Ned.
Well, fine business. And next on the list is Dev KC3PVE. Go ahead, Dev.
Hello, good evening, everyone. As Nathaniel suggested, we met, I think, today in the morning at the University of Scranton for our regular group meeting. But the group meeting was last one for the summer, as I think we concluded our summer research program here at the University of Scranton. And I've also written an FGU abstract, and I think I'll be submitting it this evening, in a while, or tomorrow. Thank you.
Very good. And next on the list is Michael, AA8K. Go ahead, Michael.
I wasn't muted. Greetings to everyone. Back to you, David.
Fine business. And next on the list is Brian, AD2BA. Go ahead.
Hi, it's been a while since I've been able to make one of these, so I'm just dropping in and getting reacquainted. Back to Ned.
Fine business. Welcome back. Next on the list, we have Dan, N4XWE. Go ahead, Dan.
Thank you, Dave, and good evening all. Just kind of putzing around a little bit with radio sound receivers, and that is really about it. Back to you, Dave.
Well, good. And next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone. Continuing to work on existing radio systems. I was hoping to get some data from Scotty, but I haven't seen it yet to try to help with an adapter for the Max 10 test bed, but more should be revealed. Back to Ned.
Well, fine business. And next on the list is David, the Ohio David. Go ahead.
I know my name is hard. It's actually a Scottish name.
Okay.
So it's pronounced Waugh. But I've heard every possible combination and things that aren't repeatable. But hello, everyone. Good to see everyone. I think I sent yesterday an email to the list where I was trying to look at some distance metrics to compare magnetometer readings, and I think that may have been not particularly useful, although I learned some things about how to get data into R, mostly that I don't know what I'm doing. But after a long time of getting stuff in there, I think distance metrics are more complicated than I realized. And the data is, it may be the wrong way to look at, well, I don't know. And I also noticed that the number of readings per second is, down somewhat from what should be a full day. I'm not sure I think the timestamps are correct, and I don't know if it makes much of a difference, and I only noticed that because I was trying to get columns of data into a computer that did what I told it, not what I wanted. Other than that, back to Dave.
Fine business. And let's see, next on the list is Dave Whitten. Go ahead, Dave.
Hello, I hope you can hear me. Can you hear me?
Yes.
Okay, I fired up my usual computer and I had rebooted it today with some updates, and of course it doesn't like my microphone anymore. So I came and fired up this one, which really has been sitting on standby since about April, but it seemed to come up. Not a lot of excitement. I was out of town last week, most of the some of the week, and haven't been very productive. So that's all.
Well, fine business. And next on the list, we have Hillman, KD2 MCR.
Good evening, everyone. Yeah, I guess I don't really have much to report this week. Sorry that I wasn't really so responsive to some of the emails that came to me. I'm in the process of moving to a new place. I was really caught up with the closings and then moving process. Last week also, I was busy with a GEM workshop where some of the agenda was to talk about, discuss the decadal survey in which a bunch of space scientists tried to come up with the idea, to what type of scientific research has to be focused in the next 10 years. And of course, some of the ideas that we discussed was about the expansion and augmentation of ground instrumentations, including, of course, magnetometers. And citizen science participation was also getting lots of attention these days. So combining those two, citizen science and magnetometer work on the ground, yes, we're getting lots of attention. So that's something that we should really pay attention to. And I'm really glad that I'm part of it. So that's all I have to say. Back to Nat.
Fine business. Next on the list is James, KG4DSG. Go ahead, James.
Good evening, Dave and the group. Nothing much to report here, and with that, back to the net.
Okay, and next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. Well, I haven't been doing too much related to radio this week. I'm continuing to accumulate data with my Grape 1. That's about it. I did find why I had so little memory on that card, and I'm embarrassed to say that it was my fault. I had remembered distinctly issuing the command to the Raspberry Pi to use all of the memory. Unfortunately, I had forgotten that that was not on the formatting of the SD card as I have it now. So I, in fact, had not enabled all of the memory on the card to be used. I have now, and so I should be in good shape. Otherwise, nothing to report from here. Back to Net, K4BSE.
Fine business. And next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, Dave, and everyone on the in the meeting here. A little bit busy here. The Grape continues to record data, and right now it's not because I've been working on putting a signal on the air. I received a Max 10 board, got it and the software all running, so I think I'm able to help out with that particular part of the project. Scotty tells me that there's going to be an interface, a mechanical interface board that needs to be put on there, and I'll be waiting for that to arrive. I did battle with the American Geophysical Union website and was not successful, and had to ask Nathaniel for some help getting that going. that has got to be the least I don't know what to say, the least useful website I've encountered.
It's better than it was last year.
Okay. Boy, I tell you, that was a chore. And it took me we're using 2 different computers and 2 different browsers on each computer just to try to get to become a member of that thing. It did take my money. But anyway, I appreciate the help, Nathaniel.
Yeah.
And let me think. Years ago, I spent 7 or 8 years chasing down faint asteroids that were in danger of being lost. Lowell Observatory here in Flagstaff put out a list of we desperately need current observations before we totally lose these. And I spent about 7 or 8 years doing that. And the backyard telescope had a data link coming into the house. About half or 2/3 of it's underground. And it turns out that my 2-meter transmitter, I operate a WinLink gateway, a packet gateway on 2 meters. And that 15-watt transmitter, or whatever I was running at the time, I think it was roughly 10 or 15 watts, got into the data link and really corrupted the data. So that's a problem. But the biggest challenge is that I'm able to generate a very nice chirp and a very nice tick, mimicking the WWV once per second tick, and then a chirp that goes from basically 0 to 5,000 hertz in, I think it's a 20th of a second. However, Steve tells me that I really need to be on amplitude or ancient modulation, and I haven't used that since 1960. But I've been trying to transmit this chirp and this. I could do it fine on sideband, no problem with that. But I've been trying to transmit it on AM, and all I get is 60 cycle hum. And this is really puzzling because I have actually disconnected everything from the radio except for a microphone, and then I've taken the microphone off and use the push button on the front panel to go into transmit. Everything is all the wires, connections, and everything else are disconnected from the radio except for a 20-meter dipole, and all I get is a loud hum. And the hum is just about as loud as I am when I use the microphone. I can disconnect the microphone and the hum is still there. Or I can try to talk, and I have to compete pretty strongly with this 60 cycle hum. And the interesting thing is that both the transmitter and the receiver are running off lithium batteries. There's no other connections except for an antenna, and in one the microphone and the other a headphone. And I'm getting all of this doggone hum, and I can't figure out where it's coming from. So I've been batting my head against the wall, and my grape has stopped recording things because I had to disconnect it while transmitting on 20 meters. Anyway, that's what I've been up to. Kind of a busy time. Go ahead, Dave.
Well, fine business. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I wanted to thank everybody that was involved in that email thread. There was a lot of great discussion in mitigating noise and voltage spikes, and a lot of great design ideas and guidelines. The unfortunate thing is none of that was the issue. I was messing around with my VLF preamp, and what was going on was the input was being pulled down, like I said, but I thought that was due to a failed DC-to-DC converter. It turns out that the DC-to-DC converter was still working fine. So what I did was I ordered a bunch of new ones, and I was
trying them out, thinking that, well, it was a failure. I'll just put this new one in and I'll be back and running. Well, it turns out that for whatever strange reason, is when I connect it to my test box, even a DC-DC converter that's not even in the receiver, that's just that has its output floating, it also pulls down the voltage. It's really, really, really weird. And I've been pulling my hair out trying to figure out what it was in this test box. Now I've even changed the DC to DC converter in the test box. And it's the same thing. And it's so weird because it was working fine, and all of a sudden, the voltage is being pulled down like it's a short. But I checked for shorts. I made sure that everything everything was soldered right. I mean, everything looks good. There's no shorts. There's no evidence of anything that points me to this problem. But one thing that I will note is that the way this DC to DC converter is powered, like I said, so it is so the DC to DC converter is daisy chained, so the DC to DC converter in the test box, its output, its isolated output, connects to the input of the DC to DC converter in the VLF preamp. So that loop right there is isolated, and I don't know if there's some weird sort of feedback thing going on, but it is driving me nuts. I have been messing with this the whole weekend, and I still cannot figure it out. I did talk to Paul Nicholson, the author of VLF RX Tools. He mentioned that he uses the same model DC to DC converter, except that it has a 12 volt input instead of a 24 volt input. So the voltage input range is lower. I'm going to try that because I'm out of ideas, and I really have no idea what to do. But that's what he used, and I meant I meant to order that, but I did not by mistake. I remember that I should have ordered it. But anyway, I'm still working on this issue and trying to get it resolved. That's all I have. Back to the net.
Well,
Question.
go ahead.
Yeah, Jonathan, are you using bypass capacitors on the input and the output of that DC converter? Some converters require a capacitor right there very close to it to keep from doing very strange things. Do you have a couple of capacitors on the input and the output?
I have some 0.01s on the output of both DC to DC converters, not on the input. Paul's original design, which he did exactly the same thing that I did. He did not add any input capacitance to the DC to DC converter. He drives it directly from a wall wart, and he didn't have any issue with the long loop length, except for one time, but he had to parallel the pairs. But according to the data sheet, the input bypassing the input is not critical, and this is also where this circuit has worked perfectly without them. I didn't add them because I didn't have room, but the original design didn't call for it, and it originally worked well. So I was thinking about that, but I don't think that's going to fix the problem. But I'm willing to try anything at this point. So I'm going to see if that would work. But so I will keep the group updated if I find something out.
Okay, well, next on the list is Jules, K2KGJ. Go ahead, Jules. Mike,
There we go. How about now?
there you go.
Yeah, didn't see the unmute. Okay, Nat, a couple of questions that came up this week that Dave Wall and I were talking about regarding the timing on the collection of data for the magnetometer, and namely the 1 second periods. Dave had been comparing my records, his records, and yours, Dave's, and has found that they're not quite synchronous. There are patches of data missing here and there, mainly due to apparently to a slight difference in timing and on that 1 second tick. So Dave wouldn't originally set it up. It was basically based on a delay before the next sample was taken. But this is basically a question for Hyman. How accurate do we need to be with the mag data in terms of those 1 second points? Should we be aligning it in the same way that we're aligning data from the grape and other things? In other words, using the same kind of time basis, or isn't it as critical? That's a question I have for you, Hyman. Other than that, not much to report. Jonathan, one thing you might check if you don't have enough room, if you look for an MLCC cap rating of somewhere 5 to 10 microfarads, you can find the appropriate voltage. That is a very small chip, and you can probably just tack it into the board just to test and see if it does make any difference. Anyway, back to Net. And again, Hyman, if you could think about that and give us some advice. Thank you.
Okay, next on the list is Khan. Go ahead, Khan.
Hey, y'all, good evening. What is that? Yeah, I reached my milestone with my app. So now I'm back to learning about radio. I just installed the new radio 3.10 this afternoon, and I'm working out a few bugs and kinks. I might have to program a custom block for my SDR, since the new radio is kind of new and my SDR is like it's old. So yeah, that might be a challenge. So but other than that, that's it. I'm just learning, going along. Back to the Net.
Okay. Next on the list is Robinette. Go ahead, Rob.
Oh, hello, everyone. I'm only an occasional visitor, but I've come when I've been working on some things that maybe seem relevant to you. I don't know. Most recently, I've been working. There's been an effort to extend the analysis of the WSPR database, and I've been my WSPR daemon group has been joined by a couple of big data analysis people, data mining experts, who are starting to look into how machine learning could be applied to the WSPR database. And of course, what we want to do is associate the the WSPR, the spot database, and the noise level database, which we're also recording. Associate that data with other events, and I think, of course, the magnetometer and other space weather data would be primary candidates for doing so. So I have some people who are actively looking for how to, what to look at, and that would be of interest to this community and others. In associations between WSPR net, WSPR spots, and other data, and other data, that kind of data that you guys are gathering. So if there's if someone is interested in that, we have the data in place. At least our spot data goes all the way back to 2008. But we're looking for other data sets that would be of interest. Earthquakes seem like a really silly one to be using. I think we've already dismissed those as being very unlikely. You're uncorrelated with the atmospheric data. But I'm sure there are other things that would be of interest. And we have people who've been working for Twitter and Yahoo and so on, looking at petabytes of data, interested in applying the techniques that they know to the data that we're gathering. So if that's of interest, please contact me, and I'll be doing we'll be pursuing what interests us, but I suspect you guys know a lot more about what would be relevant to correlate with the spot and background noise data that we have. So that's one topic. The other topic of potential interest is, at least for the spot database, I think we're probably all aware. If you're not, I can show you how skewed the WSPR transmit location sites are. And to the extent that WSPR data is going to be useful for monitoring the atmospheric conditions, ionospheric conditions around the world, there's some big holes in where there's very few transmit sites. I mean, I think there's only one in India. So to that end, Roland HB9HQQ has started to, he funded himself the deployment of a number of WSPR transmitters at geographically diverse locations, including some that are, especially ones that are not currently served. And you can see, let's see if I can share with you. Can I share a window here?
Go ahead.
Yeah, this is here's the map of the sites that that are in process. The green dots represent transmit sites that are on air right now, and the red dots are ones that are in process, where there are people who committed to deploy them. As you can see, there's still some big holes. South Pacific, in particular, seems to have no WSPR transmitters out there. So, and the polar regions. So that's my third topic. But in any case, all these sites are using 200 milliwatt. They're using Zactec transmitters. They're using roughly the same, vertical antennas and transmit in a sequence from 80 meters through 10 meters. And Roland's goal is to provide a richer data set and, of course, more geographically diverse data than we've had to date for access for whoever wants to use it. It's going into, the regular WSPRnet database. Of course, the big missing piece here is the polar regions. And Roland and some others seem to have been reaching out and seem to have found some interest in the NSF community in seeing if we couldn't put not only receive sites, but perhaps even some WSPR transmit sites up in the polar regions. Of course, Antarctica is a much better candidate than the North Pole. So that's the other area of activity where I'm not really directly involved in the transmitter side of it, but I think there seems to be some interest among institutions that I really don't know much about. Nathaniel, you and others may be much more familiar with this, but if getting some transmitters into polar regions would be useful to this effort. This may, he's being very active, and perhaps this is something that you, Nathaniel, or others within the group have already pursued. But if not, Roland's looking into that, and perhaps there's an opportunity to collaborate. So those are the three topics that I had that I thought were relevant, and I'll send it back to the net.
Dave, there has been a WSPR transmitter down in Antarctica off and on. I don't know if it's still there.
Yes, there is. DP0, whatever is there.
Right.
There's that one site, and we are working. Been trying to help Bill Lyles set up a WSPR receive site up at Ellesmere Island. that might happen this summer. I mean, there's a possibility that that receive site could go up. That would be one of our Kiwi with Whisper Daemon kind of setups. But that is not a transmit site. So there's, it would be, I think it would be good to have both, but in any case, if there's interest in doing that, that's about right now. DP0, that DP0 German station is the only one that's it. And of course, there's some balloons that fly over, the polar regions, but they're not really very. I don't think provide very useful data.
Last spring, I worked I think it was VY0 ERC way up at 80 degrees north at some polar research station run by Canada. Maybe you could get hold of those people.
No, that's VP. That's Bill Lyles and Pierre. They're the ones that up that's the station they're at, and they have a transmitter. They have one of the reverse beacon network transmitters up there. So it's been in operation, but they don't have, and of course they have regular SSB and so on conversations when they turn that on, but they don't have a Whisper transmit running 24/7. And I think that, Whisper has a potential. I mean, properly implemented, there's 20 or more dB gain in signal noise ratio. So it seems like Whisper, especially at maybe, 5-watt Whisper transmitters at these polar locations, might offer the data that are currently unavailable from and of course generating a wider group of locations would also be, I think, one of the goals that Roland has. So.
Thank you.
And
another polar region that you might be able to reach is Svalbard.
Yeah.
I occasionally either get somebody receiving or transmitting from Svalbard.
Yeah, Rob, I would definitely be interested in talking with you some more. I know I've started working on a proposal to do some amateur radio stuff down in Antarctica. We're having Gareth Perry lead that proposal. And of course, at NJIT, they have a whole mechanism for getting things down to Antarctica. So far, we've been coordinating with Bill Lyles a bit on that proposal. I don't think we've talked about, in fact, we've said that we weren't going to put a transmit capability in there, but I think a lot of that was like concerns over licensing. And so I don't know.
That's one of my big questions. My first question was, what's the regulatory environment down there? Can you? I'm told that part of the conversations we did hear that all of those stations in Antarctica do have internet access.
Yeah.
And the FCC regulations would allow you to put a beacon if it were under remote control, and if we have internet connection, we can control it. But I don't know if that would qualify, et cetera. I know there are many issues here that I'm familiar with, but
well, I think that would be really good for us to talk about, because I don't know all the rules on. I don't think I'm as familiar with the rules on the Whisper remote control and transmitting as you are. And I think Gareth is busy on another proposal right now, but hopefully as soon as he's done with that one, he's going to get back to this one. And I think, maybe putting this in would make a lot of sense.
Well, I just make sure it'd be a shame to duplicate efforts here and confuse the funding agencies. So I thought it would be good to let you know, and I'll forward you what I know about it, and we could set up a call or something if you want to. Most of this stuff happens. Well, this is happening here on the West Coast. It's not actually Roland. The polar stuff is going on with the big data guys. Actually, brought in Sergey Brin, his wife, who's funding various philanthropic things, among them radio studies. So. And that's how we got into this polar thing. So,
well, a lot of us do polar research, so you should be talking to this.
Yeah. So maybe we should set up another another call to kind of, like you said, make sure we don't duplicate efforts and we do, figure out what the best strategy is. And the other thing is, Bill Engelke here and myself and Phil Erickson, we just got a NASA grant to do some machine learning on WhisperNet, PSK reporter, RBN data to look at traveling atmospheric disturbances. And so, yeah, maybe we should also touch base with you to see how we're doing that, and either to make sure we don't duplicate efforts or to see how we can complement each other.
Okay. Okay. Well, I'll send you an email with and I'll CC Stu Ogawa, who is the machine learning friend, my friend who's shown a lot of interest. He's KB9YVV or something. He's just put up one of those. He's the West Coast transmitter of Roland's network. But
Okay.
Stu is far more interested in analytics, receive analytics, than he is in transmitting, as I am. I'm much less interested in the transmit part of it. So Stu is a very, deeply experienced in this field, and has brought in some of his colleagues who share his interest in applying their machine learning technologies to radio analysis for radio reception. So.
Okay, that sounds
You
really
might have
good.
some good collaborators. So.
Yeah, so we should definitely set up a meeting between them and Bill Engelke and Bill and myself, and we should get this touch base on all this.
Okay.
Well,
Great.
we have 3 more or 4 more. I want to catch Kong. He came in late, so go ahead, Kong.
Hello everyone. There's not much for me this week. I mainly tried to learn how to use the signal tab analyzer in the Chorus program. It's not a whole lot of progress because I'm not too familiar with it, but I'm learning more and more every single day. So I guess that's a good thing. Yeah, that's it for me. Back to you, Dave.
Okay, and I'm gonna jump and catch Vince. Vince, are you there?
Yes, good evening.
Go ahead.
Hi. Vince, last name Bombardier. I'm W0TLG, based in Kansas City, Kansas area. And I'm here because of an article in QST, and I'm sparked an interest, and I'm working on getting involved.
Well, very good. I'm a fairly near neighbor of you. I'm in Columbia, Missouri, and we meet here Monday nights regularly and discuss things. We have a roll call, and then we discuss building issues, and we haven't got to building issues yet, but we've got 2 more on the list. So I'm going to go ahead and go on. Next on the list is Scotty, WA2 DFI. Go ahead, Scotty. Well, his beach is there.
There I am. I got a privacy screen that I made, a Post-it note.
Oh,
anyway, since I don't have the fancy camera with the shutters on it. At any rate, just spending some time on the magnetometer, and got it almost to the point where we're done. I'd like to share if I can here.
Go ahead.
So this is the Rev E, the final placement, and actually we can do a composite, and you can see where it's all the routing and everything underneath, but it's a little bit busy when you do that. So the top assembly's here anyway. And so we're actually going to do a production or a prototype run of 10 pieces of this. TAPR's funded it, so we're going to go with it. And I think the layout is pretty much done. I wanted to run this by the guys on here to make sure that I caught everything. I sent out an email and got some comments back. Thanks, Dave. And see if there's anything else that I missed that was one of the off my list of improvements or changes that need to be made from Rev E. And this will fit in a 1.5-inch pipe. We're going to ship it with this connector and this header and this header and this header not installed. Everything else is surface mount. So it's going to be installed from the factory. So we got the assembly cost down as cheap as we can possibly get it. And so assuming that we build a set of 10 of these, there'll be 5 sets to go out to people who can check them out and make sure that they're going to dovetail with the instructions that I think Jules and Dave have been working on getting things to fit in the pipe. And then we'll be able to go into production with these things. So the question I really have that's unanswered, this is pretty much for Nathaniel, is how many do we make? It's like, because they're not that expensive and we need to make as many as we possibly can to keep the cost down.
Mm-hmm.
So, and the idea is that what the plan is to make it for the electronic part is a single kit, which will consist of 2 boards with all the SMT parts on them and a bag of parts, which will be the through-hole parts that you get to install, depending on whether you need them or not. And so it'll be sold as a kit of a pair of boards, because that's what you're going to need to do it.
Right.
And then, well, we're going to talk to
That's
Dave.
what we're calling this, the pair, right?
Yeah, the pair. That's right. So we got the
pair
grape,
boards,
tangerine, and the pear.
So we have a whole fruit salad.
Yeah, that's the PAIR. There's the fruit.
Yes.
Wait a minute.
PEAR.
Anyway, yeah. No, we're going to rename the fruit to PAIR so that we can use 2 boards. Anyway,
Right.
So the idea is that you'll be able to buy that kit, and it'll be pretty much everything that you need. Require a little bit of soldering, and then we'll work with the pipe team to come up with the mechanical kit for the burying it in the yard.
Mhm.
And then we'll hopefully Dave can get us a part number from his buddy there in Columbia. Is he in Columbia or is he in wherever he's at anyway?
Chesterfield.
In Chesterfield, and so we can have a TAPR part number. We will not source that. We don't want to pass through. We won't get in the way of that. But we can say, when you get your kit, order this cable from this source, and it will be the right cable, the right type of cable, have the right ends on it and everything. So you'll be all set to go. So you do that, and then the second kit you would order would be the assembly kit to the pipe and the caps and the level and all the things that are determined that are necessary to put the thing together.
Yeah.
And if we make both those 2 kits available from TAPR and the cable available from Dave's vendor, then pretty much we've got the whole system and the instructions. We've got a way for users to just put their credit card in and wait a couple of days, and then do a little bit of soldering and digging, and they're on the air with the magnetometer.
This looks good, Scotty. I didn't get a chance to reply this past week, but it looks good.
Okay. Good. So, well, when we get one built, certainly you and Dave are going to get one to give us the go ahead before we go stamp out lots of them. I'm thinking on the order of Nathaniel 500.
That, I have no experience picking, numbers.
I'm just picking 500 because that's 250 sets. It's a nice round number. It'll be cheap to build, but we might end up with selling 10 of them and then be stuck with 490 boards.
It sounds good to me.
Prefer not to do that, but
yeah. Well, then we try to get them out to people and.
But it's like whisper boards, we started out, not Dave, I don't know how many we sold, if you remember on the list, but it seems like we sold like over 1,000 of those.
Yeah.
And that started out as a little, $29, buy this, plug it on your Raspberry Pi, and you're on Whisper.
Yep.
And we never thought we'd sell that many boards ever.
Well, then we also, at the start of Open HPSDR, we built a ton of Janus boards. And
600.
I don't think we've ever gotten rid of all of them, have we?
Actually, we built 650 of each, but we bought 1,000 boards.
Oh, okay.
I think we sold well over 500 Janus boards. We didn't have that many left, but we had lots of extra boards.
Yeah.
You know, Scotty, you've got a bird name in there too.
A bird?
On the right-hand side, wren.
Wren.
Oh, yeah. So it could be the, no, never mind. Could be the wren, yeah. This could go really bad really fast. too.
Yeah.
Yes.
It's the jumping wren.
You have a snake in there
So,
also,
Scotty,
I have a
an
snake.
adder. Yeah, the
Oh,
adder.
yeah, right.
I'm missing it. Where?
250
ADDR.
pairs.
Oh, jeez. So you got a bird, a snake, and a fruit.
I don't know. Mhm.
I do, before we get in a long discussion on this, I would like to give Tom McDermott a chance to give his report because he's the last one and oftentimes he likes to go at about an hour.
Oh, yes.
Tom, are you there?
Yep, I'm here. Let's see. I uploaded the document to the tangerine.com website on how to install Quartus on Ubuntu 20. And today I wrote my first Verilog program, compiled it, and got it downloaded to the test board, and it works. There's some very non-intuitive stuff in using the program.
Yes.
You have to intentionally set it up to do the wrong thing and then change it to do the right thing. And if you try to do the right thing, it doesn't work. So, but eventually it will download it. So I've got downloaded. Key issue for, I think, this group to discuss. In order to build a working receiver and perhaps clock and other things, we're going to need an FPGA software load. And I think the first step in that process is getting UDP sockets to work in the code. And I've looked online and I can't find anything related to IP for UDP sockets that doesn't require a huge expenditure of funding. And so, Scotty, if you know anything about how we could get sockets up and running on this board, that would be a good jump start. That's it.
Okay. I don't know offhand. I know there's a tri-speed Mac that you can, that's in the library. I don't know if it requires a license or not. I have to go back and look because you're running the light version of the software, right?
Yes, the light version.
So when you go into the IP catalog, you know how to go into the IP catalog, right? It's on one of the upper left corner. It's one of the actions that you can, it's under the view menu, I think. So it opens up a box on the right-hand side.
Yeah, I know how to get to the IP menu.
Okay,
and I think there's a tri-speed Mac in there, but a tri-speed Mac is, you know, a teeny tiny teensy weensy part of UDP sockets.
Right, and if you want, you know, software running under NEOS to do sockets, that's going to be a problem probably. And I think trying to remember, so I was talking to somebody about this, about
probably. I was talking to you about
maybe it was you, Dave, and you said you had found some software.
Well, there is some examples of just loading RBN or they're now called RBD files into memory. And I don't know, you're thinking of the UDP for radio data, Tom?
Right. Well, right. I mean, ultimately, the data engine's got to have UDP sockets on it, right? And that's all part of the local host to data engine interface is all the UDP sockets.
Yeah.
For me, in the meantime, to even get data out of a receiver, I got to have a socket to send it somewhere.
Right. Well, we do have some examples in Cyclone 4s and 5s, but of UDP code that was handwritten.
Okay.
So we could use that, but it depends on, and you know, you have experience with using it from the other side. So
yeah, it just strikes me this is going to be a critical software delivery in getting anything at all going.
Yes.
But you know, Phil never used sockets. He just spun his own UDP engine.
Well, okay, so he spit out he received UDP packets, he transmitted UDP packets, right? That's the next thing down. Of course, then you have to handwrite DHCP and all of that other stuff.
Right.
Yes.
So at any rate, I think we need to figure out, maybe we should do this offline, figure out what we're going to do.
Yes, I think we probably ought to have a session on this for the FPGA programmers.
Right.
And so we
Okay.
can work on that.
That's it.
Okay, so I think we've gone through everybody on the list and took up most of the hour. And Scotty, I don't know if you had more development work stuff to talk about. I would want to mention to everybody that DCC is coming and we're going to be calling for papers, or actually I think the call is out. So it'll be virtual this year, and we're going to have 30-minute talk windows and some 15-minute talks as well. And we're trying to run the time frame so it's more convenient for the people all the way across North America.
It'll start a little later.
Yes.
One thing.
And end a little later, or a little earlier.
Dave, can I ask, are there any specific talks that TAPR would want from like the Personal Space Weather Station Tangerine group at all?
Well, we were kind of assuming that we would have some of those.
Kind of like a replay of last year.
But
well,
both Scotty and I are deeply involved in parts of the presentation and running the Zoom software. So I just wanted you to be aware of that.
oh yeah. So I mean, I guess, what we've done in the past years is basically gone through and I've asked everyone who is like a part of the team, I asked Scotty to talk about Tangerine. Asked Yeoman, Dave Witten, and Jules to talk about Magnetometer. I gave the overview talk. We had Bill giving a talk on software. I guess we can rehash some of those, or is there something, newer that you think would be a better approach?
We would like papers that talk about all these components, but probably not just overviews, but there probably needs to be one overview, but more details that have been developed in the last year.
Yeah, kind of like where we're at kind of thing.
Right.
Well, I would like to have somebody give an explanation of the magnetometer so that I don't have to explain what it is when I get ready to talk about the RF exposure testing on it.
Okay. So
I'm hoping that we can get somebody to give a 15 to 30-minute presentation on the magnetometer, the design of it, plans for it, how it works, what it is, so that when I say I tested this thing for RF, I don't have to first explain what it is.
Yep, I understand.
Well, I can certainly have Dev can give an updated talk on his Spread F project. He's been making a lot of good progress on that.
Yes, and I think that's a good topic because it's probably not well known among the hams that would attend the meeting.
Also, Nathaniel, if you maybe we can enlist some of the case people in helping to be moderators.
Yeah.
Like
So
I think Christina and those guys helped last year a lot.
Mm-hmm. And we can try to get some of so we can definitely get some of the case people. And, we have a whole slew of students now at Scranton who I'm sure could help to be moderators as well. Okay. Right, Kung?
Absolutely.
Yeah, so, see, you have one right there. One more volunteer. I'm sure we can easily get the other Scranton people to help out as well. Let's see. So, Veronica can give an updated talk on what she's been doing with the analysis of the grape TID data. I can give a talk on my updated TID analysis using the Whisper PSK reporter data. Does all this sound good to you?
Yes,
Okay.
it does.
So
Because I remember is that the first morning we spent pretty much on Space Weather Station topics, and then it kind of graduated into more scientific topics in the afternoon.
Yes. So I think what we'll do, so as I said, the AGU abstracts are all due on Wednesday. So I'm just going to think about AGU until Wednesday. And then Thursday morning is the Case Western Telecon. I think at the Case Western Telecon on Thursday, I'll start thinking about, we'll make up a list of all the people for TAPR DCC.
TAPR is mid-September.
Right.
Is it?
The 17th and 18th, I think.
Well, I'm not sure. I saw
Hold on.
somebody put a 11th and 12th.
No, that's not right.
That was somebody made a mistake.
It's 17th and 18th.
Yes.
Yeah.
That's a Friday and a Saturday.
Okay, and I remember what I did last year is I teach classes on that Friday, at least for my digital signal processing class. I canceled my class and I made all of them watch at least two.
Watch this.
Yeah, watch at least two TAPR DCC presentations, and then they had to write up a paragraph about it and turn that in for their homework for that day. So, but the other rule is, Kung, if you're helping out at the TAPR DCC, if you're either giving a presentation or helping out, then you don't have to write anything. So you get out of an assignment because you're already doing work.
That works for me.
I can tackle the magnetometer description for Bill.
Oh, good.
I have a complaint. Why
Yes.
does everybody schedule things on the same weekend? That weekend we have a 100-mile run that we have to support that takes up basically all of Saturday and Sunday. It's just absolutely unreal.
What about Friday?
Well, we'll be getting ready for the run, but it's not a big deal.
Okay, because most of TAPR it's on Friday and Saturday, not so much on Sunday.
So Joe, what is that run? That's not the Highline run, Canal Run, is it?
That's the stagecoach run from Flagstaff up to the Grand Canyon. It's a combination 100-mile foot run and bicycle.
Wow. Okay.
We used to have.
And it's 30 hours, so it takes up the whole weekend.
We used to have an MS 150-mile bike ride.
We used to have that one here too.
Yeah, and that took a whole weekend to support. But they
They used to call it was the best dam bike ride because it was from Phoenix to the Parker Dam. So they called it the best dam bike ride. And it raised tons of money for MS.
Yes. Our bike ride moved to the Illinois side of St. Louis.
It's East St. Louis.
Well, it's North Alton area.
Oh, okay.
It's where they run it.
What was interesting out here is that we had two mountaintops that we put repeaters on that they linked together for the event. And we actually had amateur coverage over the entire 150-mile course.
Wow.
Which was pretty amazing but only because there are mountaintops on either side and flat desert in between. And that.
So sorry, Joe, we just have to pick a weekend somewhere.
Yeah, I know.
Traditionally,
but,
DCC is mid-September.
Yeah, it's just being rather amusing watching how many people want to do something at the same time. 10 o'clock Saturday morning is also a very, very busy time.
Yeah.
So 2 years ago, the Congress Club and the Tucson Club arranged their swap meets on the same day in November. And they're, one of them is about 40 miles west of Phoenix. The other one's about 90 miles south of Phoenix. So here you have, in Arizona, you have no swap meets at all. Then all of a sudden you have two that are on the same weekend, same day. And it's like, you have to pick, you can't go to both.
Yeah, that's tricky.
Yeah, so
So I think, so I guess, Dave, what I'll do is on a Thursday, I'll sit down with the Case Western group and we'll try and come up with a list of names and talks that we think we could do from that group. And then I'll send it to you and I can bring it to this group next Monday and we can try to finish filling out the list with this group.
Yeah.
And that should be enough. That should make it, because the call deadline is August 15th, right?
Yes.
So
It's, there should be something in the PSR.
right. I read that was August 15th. So next Monday is the 9th. So if we have a draft of everything, all the abstracts we would submit by next Monday, by mid next week, we'll be fine for getting that deadline in.
and then the recordings aren't due until like
The weekend before.
Right?
Yes.
So like the 11th and 12th of September, right?
And and we're going to do it like last year where we have a recording, but the author will be present to help with answering questions.
Okay. That sounds really good. And then with the personal space weather station, I've given a short overview talk before to kind of frame everything. Do you want me to do that again, or do you think that's not necessary?
Yes, yeah, I think that's good. And like an introduction.
Right. So
Yeah.
I like give an introduction. So you do really want something from each of the different teams then?
Yeah, yeah.
Okay.
And then we
That
can
works for me
arrange
too.
we can arrange it so that maybe like the 3 board designers share one slot. We each have like 10 minutes.
Yeah.
And then you have a
So,
15-minute intro. or
Now,
something like that.
Scotty, you like to take up, we were talking, we have 30-minute sessions with 20 minutes for the talk.
Okay,
and
so
10 minutes for
6
questions.
minutes each then. But you know how hard it's going to be to get me to talk in 6 minutes.
Scotty always produces 60 slides for a 30-minute talk.
And there's not much new to say on that hasn't been said over and over again on the magnetometer that can be said worthwhile to my way of thinking in 6 minutes.
Yeah, well, except for the fact that we just about to be able to release it, and we have a
Someone can say
container. The container is new.
There's quite a bit new about the magnetometer. I guess just not necessarily all about the board. But I mean, first of all, so you do have the new revision of the board, which Scotty just showed tonight. You've
Scotty has it,
continued, you've continued to make additional measurements. So, you can show those, and hopefully maybe Hyomin can do some more science with those. And then, you also have Dave Whitten, your new software. And so, I mean, those are like 3 big things about the magnetometer.
Well, then
right
you have
there.
the RF limits that Bill's done.
Yeah, and then you have the whole, Bill's doing the whole RF testing. So that's a lot.
There will be people at the conference who are not familiar with it at all because they haven't sat in previous presentations about it.
Yeah.
So it's a good idea to get the word out if we want to sell 500 of them.
And then I think the most interesting part of the whole thing is how do you package it? I mean, the homebrew package and why did we do it? Why did we make it that way? And why can't you just go throw it out the window and we're all set, put it in a Ziploc and we're all set? So,
in 6 minutes.
Yeah, right.
No, now we will have time and space.
Yeah.
But we also don't want to cram a whole bunch of people into one.
Well, yeah. And maybe that's why next week we can kind of draw out what each of the different topics are that we want, so that, if the magnetometer does need more time or one board does need more time or something, we can do that appropriately.
Well, you could also do like one presenter and that person could get with the other 3 or 4 people and get the information and slides from them and put together.
Yeah, that makes sense to me because a lot of the key points we've made before, that anything new or some of the new things might want to be a separate talk entirely.
Be a little careful because there's going to be people there who have never seen any of this before, but you don't have to dwell on the stuff that's been like the architecture of the Tangerine is like, I've been giving that talk for 2 years, so I don't need to spend much time on it. It's like, here it is, really quick, next slide, and get down to the new cool stuff like the new pipe mounting and all that.
Yes.
Because that's really, I mean, for us hams, we build stuff, right? So now here's something I can build. I can get the parts and I can glue it together and I can stick it in the ground. It's not a lot of abstract arm waving. It's like, here you go, and bring one and hold it up for the screen and show it.
Yeah, I think from what Bill was saying too, that the description of the magnetometer is more hardware oriented, or that is to say, oriented in a way that's related to his interference testing.
Yeah, that's a specific topic. You know, it deserves its own.
Yeah, well, I mean, but it's
but
just a description. I think, Dave, a description of the, you know, here's the RM3100 sitting out there. Here's basically how it works. Here's how it communicates with the Pi itself back in the wherever that's located. And these are the elements that potentially are susceptible to interference. But that basic description says how the hardware works. The software is a separate item.
Yeah. And we've been looking at this so long that we just intuitively know how the hardware works because we've been seeing it over and over and over again. Yeah. But it's not necessarily, I mean, I think it's pretty easy for hams to understand because they're technical, but we have to explain, we have to show them what it, with a few slides.
There's a lot about this project that isn't strictly traditional ham territory.
Yeah.
And so, yes, they'll understand the electromagnetic aspects of things very well, but some of this is about data and distributed, the advantages of doing distributed acquisition of data and processing of that data for different purposes.
At this point, we have
dealt with separately, I think.
And at this point,
detail.
Thanks to Dave, we have actual data in a database online.
Yeah, and the data is, I mean, that distributed sources of data is part of the whole HamSci project. Magnetometer is a piece of that, and you know, Dave's got that stuff online, but that's essentially remains the entire HamSci project, getting that data out and getting it from distributed sources.
Yeah, and we're trying to do the same thing, a similar sort of thing with the grape data as well.
Right. So it's all the data coming out of HamSci.
But then this really is like a microcosm of the whole HamSci project, right? This is the first thing that we got that actually collects some data. And then we've got the first thing that actually has a database that we can put the data in. And the first thing that has multiple, you know, more than 3 or 4 people. I mean, maybe the grape is in there too, because it's kind of in parallel.
Yeah, I think the grape and the magnetometer are kind of at similar places.
Yeah.
I need to go, but I wanted to check with Nathaniel. Are we having our FPGA session this week?
Yes.
Okay.
And then Kung is officially, this is the last week of Kung's official employment for the summer.
Okay.
And then so we can talk about how we want to continue for, you know, the upcoming year.
Okay.
Okay.
And there's a Thursday morning meeting for Grape, right?
Yes. And at the Thursday morning meeting for Grape, as I said, we'll probably talk about what we're going to be doing for the TAPR DCC. So.
And is that at 11?
10. Well, 10 a.m. Eastern. So.
Yeah.
So what's that, 7 or 8?
7 our time. 7 in Arizona.
We need to send you more coffee, Scotty.
Yeah. Need to start drinking coffee.
Could send you some Diet Cokes.
73. I need to go.
I'm going to start a meeting. Schedule it at 10 p.m.
I
Mountain
have to
time.
leave here also. See you next week.
Thank you, Jules. 7-3. Yes.
Can I ask a question? Well, Scotty mentioned throwing the magnetometer out the window, which I don't
That
think
was
he
supposed to be a joke.
No, but it brings up an interesting point regarding the orientation of it, and given that professional magnetometer sites have ways of aligning things to true north, or there are all kinds of precise alignment issues, and users at home, I don't think will. Is there any reason why the magnetometer could not be at a random orientation and then mathematically the vectors turn to some nominal direction, whether it's true north or magnetic north for that location? Ideally, I guess ultimately, I don't think users will be able to position things repeatably. And
But actually,
if you null out, to magnetic north, that changes over time.
Well, actually, you can, because you can get them orthogonal, because they're built on the board that way. And if you can mount the board using Dave's brackets so that it is exactly vertical within the pipe, and then what we do is we put a level on top of the pipe, and you can get the pipe vertical in both axes.
But I definitely take David Wow's point. Like, over time, if hundreds or thousands of people go put this out there, not everyone's going to do it perfectly, and then someone's dog bumps the thing.
You already have to have at least a XYZ table because they're not lined up the way we put them in the pipe.
Is there this is out of my depth, but and I know we've discussed this before, but is there, since what we want is 3 vectors out of a that may be transposed somewhat in each.
No, it only takes 3 numbers to do a rotation on it, and you can
Right.
calibrate it any way you want.
Well, and that's what I was thinking about, is that, I have the bubble level, and I think I tried to align to true north, and there's a given amount of error there. I haven't tried nulling it, which I guess is the preferred method to getting it to make the y-axis with the smallest signal, but there's going to be, that's going to be whatever my local error is, and ability to, and I guess someone has to be shouting the numbers at me while I'm doing this, because there can't be anything magnetic nearby. But I was just wondering if you got it, the axes are orthogonal on the board, and if you have them orthogonal in the pipe, why not just put it in the ground, point it sort of true magnetic north, and then turn it 45 degrees to one direction, and then via later corrections turn it in some direction.
Ultimately, I think that's what's going to happen anyway, because once you get all of this data into the database, I think we're going to have some sort of data checking, cleanup, processing on the server side that looks at all the incoming data, make sure it makes sense and things like that.
It seems like you should be able to mathematically rotate it in any axis you want. That's not
right.
The problem. The problem is how do you determine where the index is?
Yeah,
Where's
that's
north?
the question is is there a way to average over some period of time?
Yeah.
The measurement.
Well, you could just take the reference magnetic field for your location, average your actual data over time, and then match to it.
That might clean things up an awful lot if we could give the user, say, okay, run this for a week, and then compare this to these numbers, or plug in these numbers from some site, And then we will know within adequate tolerances what the meaning is of the data you're collecting.
Mhm. I think, they have the IGRF model, which is downloadable and usable, and I think it'll run on a Pi. So I mean, it could really be all automatic and like hidden to the user.
Well, that's how I had determined that the magnetometer is working, because I found the numbers for my location and they made sense from what the magnetometer
Yeah,
was
I did the same thing, Dave. The other piece is that because the magnetometer calibration may be off by a few percent either way, you can use your local magnetic field from that model that you can find online to develop a correction factor for, let's say, the data. Basically you've collected data over a month or so, and now you can take that averaging stuff and make a correction factor to bring it up to what the model says it ought to be in terms of the calibration for absolute value. So that's another piece.
And I think the error in the model is going to be probably less than what the average person can actually align the direction of the tube.
Yeah, and ultimately, it's the relative values we care about anyway, the changes.
If we can do that, I think that would be a big step forward in the usability of this on a broad scale.
Yeah, I agree. I think, for all of these sensors, there has to be as little user interaction in the calibration as possible. There has to be as much automatic algorithmic calibration as we can.
I agree with Dave that because we do have the level, we can get that at least 2 axes correct, or within a degree or so with the level. And then the y-axis, if you basically just roughly point at magnetic north, then you can do the correction afterward mathematically. But at least I think you need to start out with not just dumping the pipe in at a random angle and so on and so forth, but use the level and try to get it roughly magnetic north in your area, and that's as good as you need to do.
Yeah.
And everybody should be able to do that.
Since we know already the XYZ that it sends and true XYZ are different, you already have to have at least that form of rotation in the data record. You might as well build in a full rotation capability.
And
I think
I believe the directionality of this type of sensor may not be that good compared to the traditional like flux gate magnetometers. So unless you make really a big mistake in orientation, I don't think that can propagate to the orientation issue. So as long as you do a decent job in orienting the sensor, I guess what we care, what we care is variation, relative variation.
Well, we need to be clear how we ask people to align it. And are you aligning to true north or to magnetic north?
Magnetic north.
Or what?
Magnetic
and
north.
The thing is that you also don't know what your magnetic anomalies in your area are.
So the advantage to pointing it towards true north and pointing 45 degrees one way or the other would be is you would avoid the declination being positive or negative, and so you would just move into a territory where you didn't have to worry about that, and because if you're trying to align to magnetic north and there's error, you could be getting into
but Dave, your compass is going to read magnetic north, and if true north depends upon your declination, which you then have to know. So you're better off just aligning magnetic north.
Yeah.
Well, but either that or you do it at night when you can see the North Star.
And almost everybody.
The astronomers know where true north is.
Yeah, almost everybody here has a very different, where I live and Dave Larson live is the declination's pretty close to zero, but everybody else is very different than that.
Yeah, I'm 13 degrees.
Yeah, and we can, if we could automate that correction, or at least make it, give as simple instructions that say, point it at magnetic north, make sure it's vertical.
Mhm.
And then from there, click on this button and get your geolocation things, or put in your latitude, longitude, and we do a lookup on what the current thing is, maybe even refresh that periodically against their, refresh metadata, at least for that site, in a way that keeps that within reasonable bounds. Then we've really eliminated a lot of fiddling.
That sounds like the way to go, Dave. Yeah.
And also, if we could get some aberrational identification, things like, recognizing when a lawnmower goes by now and then, and smoothing that out of the data a little bit, that would be nice down the road too. But
Hillman, does SuperMag, do they do any cleanup of the data or rotation of the data after they get it? I thought SuperMag did some processing.
Probably they have their own processing mechanism where they actually convert whatever coordinate system to their own coordinate system, because I think the magnetometer data are reported in a different way.
Right.
Although there is some, I guess the geophysical observatories, they report true north and with declination, whereas space physics magnetometers, variometers report geomagnetic XYZ. So there has to be some kind of transformation mechanism to standardize the coordinate system, but I do not know the details.
Also, in examining a number of the magnetometers, the actual orthogonality of those three sensors is no better than about ±1 degree. Maybe
Plus
2
minus
degrees.
what?
I say if you look at the actual RM3100 and look at those three sensors, the actual orthogonality of those physical on the board is no better than about ±1 degree.
Yeah.
I think you've seen that also, Hillman.
You said ±1 degree?
I'd say, well, do you think it's more than that? Maybe I'm being too charitable.
I thought that was pretty good. ±1 degree.
Yeah, well, I don't know if we need better than that. But definitely, we're no better than that for sure. Maybe
So,
2.
Going back to Nathaniel's question, I think maybe I can just talk to Jesper about how the coordinate systems are defined there.
That's a good idea. And maybe talking about the bigger problem in general, because he's going to have a lot of experience ingesting many different magnetometers from all over the place.
But those are also magnetometers with full-time staff and equipment to do elaborate calibration.
Oh yeah, that's
right.
So,
but it's a good starting point. And
yeah.
So it's the SuperMag website. Jesper Yerlov, he's at APL still, or is he somewhere else? Yeah. So he goes and he ingests all these magnetometers from very different networks run by different people. And so, yeah, they are higher quality magnetometers, but he's still dealing with a very heterogeneous, set of magnetometers and data inputs in different coordinate systems. So he probably does have some sort of a approach for doing data checking. And I think, and the different magnetometers come in at different data rates. So I think he tries to produce a data product where you can get all of the magnetometers resampled at, say like 1 second cadence. So he has, I think, a whole processing scheme for dealing with all of this.
yeah, that would be invaluable information just to understand what their issues are.
Mm-hmm.
And see how they translate to our situation.
Yeah, that would be good. Hillman, you should get Jesper to give a guest talk at either TAPR DCC or the HamSci workshop, or, come tell us, on Monday night or something.
Yeah, that'll be nice. I'll try to reach out to him just to ask some questions and then go from there. Whether he wants to join this meeting or not.
Oh, I forgot to tell people, I got a new t-shirt today.
Vin. Dave Larson would like that.
Love it.
Yeah, I found out that my former student, Josh Vega, he used to be an ardent Emacs user. And
So you're tormenting him.
Well, so I got Rachel to take a picture of me in the shirt this morning, and I texted to him to troll him. And it turns out that he's come over and seen the light, and he's now a Vim user. So, errant souls can be saved.
I would just need to find a t-shirt for the Joe editor.
You might have to make one.
I'm going to find one for an abacus.
Well, real programmers use a magnetized needle in a steady hand.
Gentlemen, I'm going to go QRT. Good night to all. 73. We'll catch you the next time.
Yeah, I think
Thank you.
same here. I'm out of gas.
73.
7-3. Joe, do you have a minute?